let's get started. So this week is our last week for Part A. And today we're going to talk about a few new topics. So the first topic is variable scope. So variable scope, we start from an example. This example is very simple. So give you a function here. Okay, this function is called find weight. Input is m, and return value is f. And in fact, is giving any input m, ask you to compute the weight. So basically, the input multiply gravity. This is the function, what the function is talking about. So now, when you call this function, what we're going to do is, in the command window, for example, you give an input m equals 10, okay? And then you call this function, find weight m. So whenever you call this function, so you first assign 10 to m, and then you call this function, find weight. This m becomes 10. So when you call this function, MATLAB will go to the function and update this input to 10. And when they update this input and then do this computation, for gravity is given 9.81, and then here m is 10, multiply gravity is 98.1. So this is the example. Now, what happens if I give g equals 2 outside in the command window? Does this g affect the g inside the function? Huh? No. Thank you. Yes, this is correct. Why this g you define outside in the command window when does not affect this g inside function? That is our first topic today, is variable scope. This is determined by variable scope. Variable scope decide where variable live, where variables stay. So basically, there's a two possible workspace that variable can stay. So when you create variable in the command window, okay, they stay in base workspace. When you use the function, all the variable that used in the function, they stay in function workspace. These two workspaces, they don't talk to each other, okay? Seldom talk to each other. So that is why when you change something in the command window, it's most likely, if it's not input variable, okay, most likely it won't affect anything in the function. So this is variable scope. I can demonstrate you an example that's clearly observe what's going on. So this is find weight. This is the function I've been talking about. So now I give m, and I want to call this function and calculate this f. For example, we do debugging. Okay. So I press F1. So the reason I was doing step-by-step debugging is just to let you see the workspace, how it changed. So here you observe in this workspace here, you create M. Okay? So this workspace, in fact, is so this workspace is identified. It's called test, because this MATLAB file is called test. Okay, so it's a test, but this test workspace is in fact a subset of base workspace. So you go on. So now you're inside the function. Okay. So when you're inside the function, you see input argument was updated 10, gravity was assigned. Okay. And basically, when you almost finish, okay, then you go back. So you go back to main program, and then you go back. So the hidden is always base workspace. Base workspace is always there. Okay, it's having this initial value and the function's return value, and the rest variable from function where it stays function workspace. So where is function workspace? I'll explain how it worked using an example. So this is the example. This example is the same function, find weight function, and here you assign 10 to m. Okay. So when you assign 10 to m in the command window, so naturally this base workspace is there, and it put 10, m equals 10, inside the base workspace. And then you call find weight, input is 5. So when you give an input, then the MATLAB will go to this function, input is 5. Whenever MATLAB go to this function, it creates this function workspace and update input 5, okay? And then go on, gravity, update gravity, and compute. This is 5, and this is gravity. So this is what you get, 49.05, okay? So once you finish, you complete this computation, and the return value f has a value, 49.05. Once it's complete, okay, this return value will go back to the command window. Once it go back, so this function is completed, okay? The computation is complete. Then the MATLAB will remove this part, will delete this function workspace. And so when you go back, when the return value went back, it update 49.05 in the base workspace. So base workspace, whenever you define something in command window, the variables stay in base workspace. Whenever you define in M file, the variables stay in base workspace. So whenever you use function, you go into the function, then you create function workspace. But function workspace is just temporarily, okay? After you finish function computation and you have a return value, and this function workspace will be removed by MATLAB. So this is two workspace, how they interact. So this example I have demonstrated, and here just saying this, if you define a G in command window, it won't affect G in the MATLAB function, okay? So this is variable scope. This is first topic. Now we move on to the second topic. Second topic is a global variable. So the global variable will very rarely we use a global variable, but nevertheless it's a topic that we should know. So global variable, normally when you use global variable means you define a global variable, so you can use in M file, you can use inside function everywhere globally. So when you define global variable, normally you use a capital letter to define a global variable. So let's start with an example how we use a global variable. So here the green box is the main code, okay? And this blue box is just function. So this example is to saying first line. It said called global capital G. This is a declare that capital G is a global variable. Okay? So once you declare global variable, you immediately assign any value 9.81 to G. Okay? Any value to G. And then you assign 10 to T, call this function distance. Input become 10. So once you call this function, MATLAB will go to this function, okay, and update here to 10. And inside this function, you also, if you want to use this global variable, capital G, you also declare inside the function. Okay, so here you say global G. And so once you declare this, the MATLAB will understand, oh, this capital G is a global variable. and it will go back to the main function, main MATLAB code, to grab this value, 9.81, and plug into function 9.81 and times t is 10, and do this computation. Once you finish, the return value d will come back and print out everything. So as you notice, if you want to use a global variable, you must declare in both M file and the function. So both file, you can use it. Once, what happens if you miss the declaration in one part? Then it won't work. It will come out the wrong message. So I can demonstrate you here. This is the main MATLAB code I talk about, and this is the function. So now I hide this declaration. Okay. So it won't work. It said undefined function or variable g. So you must define, declare in both cases. Okay. So this is the global variable, and because of this, sometimes we say the global variable is hard to manipulate, because if you have 10 or 20 MATLAB functions, you have to declare it all. So just this part is pay attention to, okay? And that is the second topic. Second topic is very easy. Third topic is function handle. Function handle is very useful to your second part of the of this unit. It's part B. Okay. So function handle is in fact how to explain function handle. Function handle in fact is a variable. Okay. It's a variable, but this variable will represent a function. Or in other words, you can think this is a pointer. It points to the function. So how do we define function handle? Function handle is, the syntax is given here. It's like, this can be any variable name. Here we gave function handle. You can just F, you can just I, you can J. It doesn't matter. It's a variable name, okay? And assigned, the right-hand side, first is at, followed by function name. This function can be built-in function. For example, sign, at sign. That means f handle actually is a variable that it represents sign function, or it's a pointer, point to sign function. Okay, so let me demonstrate you one example. For example, I call the variable fn at sign. So this is saying fn is a function handle, is a variable that represents sign. So when you want to use this, for example, built-in function sign, you just call fn, since you defined it's a pointer, okay? Input, with the input argument 0. This is equivalent of the computation sign of 0. Okay? So this is the idea. So for example, now I define function handle fn is point to tangent. Okay? So you say this function handle with input 0 is equivalent to, say, tangent of 0. Okay? This is the idea of function handle. I'm taking the most easy example to demonstrate you. So here is a few examples that I will mainly focus on the first one. The first one is saying x giving you a vector from 0 to 2 pi, 100 points. Okay? And then you define a variable, my handle is a function handle variable, and it points to sign. And then you just plot x. X is a vector. Okay? My handle with the input argument x, this is equivalent to, say, sign of x. Okay? So let me show you this plot. So this is the plot. So So you just plot a sine of x. So any question about a function handle? Yeah.
So if you're using a function handle for
Yeah.
a function that has multiple inputs, is it still just the same?
Yeah, yeah. I'm going to talk about this. So this is function handle that working as a pointer to point to a building function. It can also point to a function that you defined. It also worked. So now I'm going to show you function handle as a pointer to the anonymous function. What's the syntax? The syntax is giving you a variable name. It's called still fn handle was assigned. The right-hand side is at brackets inputs. This is exactly like this student's question. This input can be single input, can be multiple input. Okay, this input argument. And followed by a command. Command is something you want to compute. Normally, this command line is just one line computation. For example, I say function handle at with input x. This is asks you to compute 2 multiply x plus 1. Okay, this we say this function handle is point to a function. This function actually is computing. This is too hard to write. Okay. 2x plus 1. Okay? We say this function handle is in fact point to a function. This function is computing 2x plus 1. The input argument is x. Okay? Let me demonstrate you how to do this. Fn, for example. With the input argument x, let's say x squared, x to the power of 2 plus 1. So this is saying Fn is a variable, is a function handle that's going to realize x squared plus 1, this computation. So when you call Fn, okay, when you use Fn, you give a certain input argument. For example, this x can be a vector, can be a variable, can be a single scalar, okay? So I put 10. So this is equivalent to saying, now input is 10. What you're going to do is do this computation, x squared plus 1. So x now is 10. Is 10 squared plus 1 is 101, right? 10 to the power of 2 plus 1 is just 101. Okay? So this is a function handle that point to a single line computation. We call it anonymous function. Let's see an example. There are a few examples. Here, the function handle, first let's see only this part, okay? This part is saying, now function handle called myPoly2 was defined as input argument is x, and what it's going to do is x squared, x to the power of 2 minus 10, okay? So then the second function handle, myPoly3, was assigned with the input argument x, okay, and compute this line. This line, what's this line? Is 2 times x to the power of 3 minus myPoly2 x. MyPoly2 is given the first line. So you just plug this myPoly2 in, is x to the power of 2 minus 10. This is the computation, right? And the third variable, function handle, was defined with a function, okay, that you have 2 input arguments, okay, b and c. And these 2 input arguments, with these 2 input arguments, what you're going to do is computation, square root of b squared plus c squared. And the last example is to show you today is a function handle, is a variable that point to this function. This function is what? Is using fprintf to print current date. And the input argument is empty. It can be also empty. Okay, you don't need any input argument just to print out everything. Because the input argument here is empty is because of date is a built-in function. In MATLAB, you can test this. it didn't need any input arguments, okay? So I'm going to show you here, for example, you see, without any input argument, this is a built-in function. It gives you today's state, okay? That's why there's a few examples with different input arguments. So this is anonymous function. So any comments on anonymous function? Question? Oh, good. This is just an application that we use function handle to recompute Sine-Taylor expansion that we did multiple times of this example. The Sine-Taylor series, first time we did a function, MATLAB function, how to write MATLAB function. And then we did is a if statement while condition. And then we did loops. And here is the fourth or fifth times we are doing this. So I'm not going to go the whole thing because it's a kind of repetition. So only this part. Only this part we have changed. If you compare with the previous lecture, it's for loop or while loop. This part was changed. So instead of calling function, we defined a function handle. The function handle called STFN. So was assigned, was point to this anonymous function. This one-line computation is basically compute x to n plus 1, 2n plus 1 factorial minus 1 to the n. This is just the Sine-Taylor expansion. So this is to compute. This function handle with two input arguments, x and n, okay? So once you assign to STFN, you can use it as a function. So then you say STFN with input argument x and 0. This is equivalent to say you compute this with x and 0. And then you assign to sine approx. And then you go on to add the rest of the terms with x and different n. N can be 1, can be 2, can be 3, until n max. So this is the use function handle to realize these MATLAB codes. So it's do the same thing, similar to function. So the next example is a function handle worked as a function input. It can also work as function input. Why it can work with as a function input? Because function handle is a variable at the end. Okay, it's nothing but a variable. So now we show you an example. So now we define. Look at this few line. So we define a function handle fn. It's a variable. And this variable also works as a pointer, point to this function. This is a polynomial computation. You will meet this kind of computation very often in Part B. Okay? So this is a one-line computation with the input argument x. So fn was actually point to this computation. And then fn is also a variable. So when you use this built-in function f0, you can use fn as the input, function input, with 75. What does f0 mean? f0 is to say, okay, you have this polynomial. Okay, this polynomial computation was defined in fn, for fn. So it's saying, now, if you print out fn, what is the zero crossing point? f0 is to find the zero crossing point of polynomial. Okay, and 75 is the first guess. You give a guess. For example, 75 is here. So you use f0 to automatic search. Where is the zero crossing point? It can be bigger than 75, can be smaller than 75, but it's going to search in the neighborhood of 75, where it is, the zero crossing point. And then x is defined as 40 to 90, 100 elements. Then you plot this fn, this polynomial, and x0 is here. Is this zero crossing point. Okay? So it's easy to understand in this way. Sorry, f0. Okay? So let's print out. So this blue curve is just a polynomial you compute. It's fn, the function fn.2. So this is the blue curve. And the x0, the zero crossing point is the red one. Okay? You can zoom. So the red one, the zero crossing point is hit 80. The initial value you gave is 75. So it's roughly such around close to 75. So this is the function handle as a function input. And the second example, also the similar thing, is also function handle as a function input. Okay, this is for numerical algorithm. So now these few lines that worth reading is first function handle is fn1. It was assigned by this computation. It points to this computation. What this computation is 10 exponential minus 0.1 t sine t. This is doing this computation. It's going to be decaying sine. Okay, it's a sine wave but decaying. So then, once you get define fn1 and you use fplot, this built-in function, to plot fn1, but within the range 0 to 50. So that means the t is within 0 to 50, and then you compute fn1 with this t. Okay, so this is fn1. You see, it's a function input inside of fplot. And the next line is another built-in function, QUAD. QUAD is integral. Okay, integral of what? The first function handle was assigned sine. So it's saying to compute a sine integral. And this integral range is from 0 to pi over 5. This is I. Okay, so once you compute, you print out I and also print out this value. So fplot is also is plot this decaying sine wave. So let's see this example. This example is nothing but using function handle as input. Here, so fplot and the QUAD. This is two important built-in functions. So this is the fplot of decayed sine wave. And then at the same time, it's an integral of sine x with this range, 0 to pi over 5, and this is final computation. This is two small example, just to let you know that built-in function can be the function input. Function handle can be a function input. Now we have another two topics to go. The first topic is a subfunction. So subfunction, we rarely use subfunction, okay? But nevertheless, it's a topic that we want to let you know. So subfunction, what is a subfunction? If you say I have a subfunction, that means you must have a primary function, okay? Otherwise, you can't call the subfunction. So, for example, here is a primary function, and here is subfunction. So when you have a subfunction, you must have a primary function, and this primary function, subfunction, must be in the same M file. It cannot be separated, okay? It must be in the same M file. And this M file's name is going to be coincide with the primary function name. For example, in this example, our primary function called energy difference. So this M function's name is going to be called energy difference dot M. Okay? So it must be the same as primary function. So inside the primary function, it's called potential energy minus kinetic energy. So these two, in fact, these two functions is a subfunction is defined here. Okay, one is defined here, one is defined here. So this is one point of a subfunction. And another point of subfunction is when you list a subfunction, you give in parallel with primary function. Okay? So what's the use of subfunction? One of potential use of subfunction is it can overwrite some building functions. Okay? But only locally, temporarily, inside primary function, but not globally. Okay, so of course, we didn't want you to overwrite this building function. This is just for a demonstration purpose. So this is a subfunction overwrite example. This example is to saying, if without any subfunction, just command window, you give x, for example, 1, 2, 3. Okay, it's a vector, and then you say x minus main of x. This main is average. Okay, it's a building function. It's a naturally compute average. 1 to 3, the average is 2. So it's saying 1, 2, 3 minus 2. So you get what? You get minus 1, 0, 1. Okay, if without any subfunction. But however, in this example, we're gonna show you that using subfunction, we can locally overwrite this. And what we defined is x squared average instead of x average. Okay? So here is the function. So here is function. So this is a primary function. And this is a subfunction. So this primary function is input argument x, for example, 1, 2, 3. And then you call x minus main of x. If without subfunction, main of x is just average of 1, 2, 3. Okay, so the average is going to be 2, and the minus 1, 0, 1 is what you get. However, here, we gave a subfunction called the main of x. Okay, here. So what is computation here is x to the power, and you sum them, okay? And then divide by the length. So this will temporarily, only in this MATLAB file, it will overwrite this building function. Okay? So I'm going to show you this example. So this example, let me see. So it's here. Let's see, let's call this example, okay? Let's call this function. And x, let's give 1, 2, 3. So this is what you get. It's not what we compute before, okay? It's not like what we said, this one. This one is because you didn't overwrite main of x. But here is when you overwrite main of x, you make x squared, sum of them, and take an average. So it's different from the building function. But as I said, it can only overwrite inside this primary function. Globally, the main of x is still a building function. For example, main of x will give you the correct answer. So this is the subfunction. Okay. The last topic is a nested function. Nested function is not a subfunction. Okay. Nested function is to saying two functions. Okay, one is inside the other. Okay, it's different from subfunction because subfunction is saying you have primary function, you have subfunction. They are given in parallel. Okay, they are not nested. But here, nested function is to saying give you a multiple function, and they are nested inside each other. So let's see first example. First example is a simple example. This is function name, parabola generator with input argument ABC. Okay? So inside this function, you nest one function here. This nested function is called P. Input argument is X. So what he's going to do is compute this polynomial with ABC. ABC, normally, for example, we gave ABC input argument is all 1, 1, 1, 1. So here is the equivalent to saying you are computing x squared plus x plus 1 by giving ABC all 1. Okay? So once you finish this computation, so the return value f was assigned as a function handle. So this is to show you function handle can be a return value here. So how does it work? Here. Okay. So let me say this. Call this function and give input argument 1, 1, 1. And then it will go into this function, do this polynomial, and return a function handle. Okay? So this is the return value f. What you get? What you get is a function handle. Which function? Parabola generator inside a function, p. Okay? So when you use this function handle is actually point to this function inside the parabola generator inside this function. This inside function p has input argument x. Let's make x 10. Okay? And this is what you get. All right? So this example is very special because the return value is a function handle. So when you use this function handle, you're going to give an input argument correctly. Depends on which function it points to. Okay? So this function f is actually point to p, so you're going to give input argument x. This is the nested function example. Now the next example is the same example, but then you make it as a sub-function. You pull this nested function out, make it outside of the main function. What's going to happen? If you pull the whole thing out, it was inside before. Okay, it was nested. Now you make it not nested, giving in parallel, make it a like sub-function where it works. So why it's not working? Because here you gave a function. The main function is called the parabola generator 2. Input is ABC. And then you assign a function handle p to f. F is return value. So when MATLAB saw this p, and then you give a sub-function here, MATLAB will come here, come to the second sub-function. Okay? So this sub-function is defined p. Input argument is x. And this is what you compute. But you miss something, because this sub-function is in parallel given. Okay? So it doesn't share the input argument. So the input argument ABC is not passed to this here. Okay? That's why if you run this MATLAB code, it won't work. Let me show you here. So here is what I mentioned. Okay? This is main function, and then the second sub-function, the sub-function here, ABC was not passed to the sub-function. Let's run this example. Okay? Still 1, 1, 1. Oh, sorry. I have to clear everything. So now we call this with the input argument. Okay, and f, as we say, f is a function handle, so we give our input value 10 to compute. So it won't work. So why? Is because ABC was not passed to the sub-function. So what can you change? Revise this part is you put your sub-function, you say x is input arguments. Also ABC is input arguments. Then it will work. Okay? You just put back the missing input arguments. So for example here, A, B, C, okay? And we still do this computation, call this function, this E111, okay? And F, now you X is 10, follow this input A, B, C, and then give you the same value, okay? So this is the from nested function to subfunction, okay? So that's pretty much for today's lecture. So I'll see you on Friday.